So, good afternoon. I will be starting in 5 minutes. Okay, let's start. I hope my screen is visible. So, the first question is, what are the sources of syngas production? What are the sources of syngas production? So what are the sources of syngas production? So the answer is fossil fuel, natural gas, naphtha, heavier hydrocarbons, and biomass. So we can see that sir has taught this in the class. That these are the sources of syngas that are from natural gas. After desulfurization, syngas can be produced in the case of heavy liquid hydrocarbon. After partial oxidation, syngas can be produced, and for coal, after gasification, syngas can be produced. So this will be the answers. Next is the for syngas production, reaction of steam and oxygen happens to partially oxidize the heavier hydrocarbons. For syngas production, reaction of steam and oxygen happens to partially oxidize the heavier hydrocarbons. Is it true or false? Can anybody answer? For syngas production, reaction of steam and oxygen happens to partially oxidize the heavier hydrocarbons. Yes, it is true. Because we don't do partially oxidation in case of natural gas, but for heavy hydrocarbons we do it. So it is true. Third is the hydrocarbons reacting with steam is known as catalytic reforming. Hydrocarbons reacting with steam is known as catalytic reforming. True or false?
Be false.
False, ma'am.
Yes, it is false because hydrocarbons reacting with steam is known as steam reforming. It is not catalytic reforming. Next is the what is the autothermal reaction? What is the definition of autothermal reaction? What is the definition of autothermal reaction? So, it refers to a process that couples endothermic and exothermic reactions, such as steam reforming and partial oxidation. As we know that partial oxidation is the exothermic reaction and steam reforming is the endothermic endothermic reaction. So, in partial oxidation, when heat is generated, that heat is being used in the reforming section. So, they don't use any external heat source for reacting in the steam reforming reactor. Okay, so that is why the heat is generated internally. So, that is why it is called the autothermal reaction. Next is the hydrocarbons undergo partial oxidation in an uncatalyzed process. Hydrocarbons undergo partial oxidation in an uncatalyzed process.
Hello. Am I audible, ma'am? Am I audible, ma'am?
So it is actually true because when hydrocarbons undergo partial oxidation, they don't use catalysts. But when we use catalyst, it's called catalytic partial oxidation. So I have asked here only the partial oxidation. So here the answer will be true. Next is the what are the uses of syngas? What are the uses of syngas? Yes, fuel production, electricity generations, and also here hydrogen sulfide, alkene, ammonia, which can be used as fertilizer, aldehyde, which is used in many reactions, acetic acid. There are many number of chemicals that hydrogen or carbon monoxide can produce. Next is the what is produced after propane reacts with syngas. What is produced after propene reacts with syngas? So what is produced after propane reacts with syngas? So it is the butyldehyde. So what is propene? CH3 CH double bond CH2. It reacts with CO plus H2, produces CH3 CH3 CH2 CH2 CHO. So this is the CH3 CH2 CH2 CHO is the butyldehyde. So propene, when it reacts with syngas, produces butyldehyde. Next is the discuss the syngas production reactions. So there are so many reactions. So what are the reactions? Yes, so first reaction is the steam reforming reaction, that is CH4 plus H2O reversible reaction produces carbon monoxide plus 3 moles of hydrogen. This is the steam reforming reaction. Then comes the water gas shift reactions. What is the equation of water gas shift reactions? That is the carbon monoxide reacts with steam, produces carbon dioxide plus hydrogen. This is the second reaction in the syngas production reactor. The third reaction is the dry reforming reaction. Dry reforming reaction, when methane reacts with carbon dioxide, produces 2 moles of carbon monoxide plus 2 moles of hydrogen. Another equations also are present there. They are decomposition of methane. So at the high temperature, because the first reaction, steam reforming reaction, is highly endothermic, Then water gas reaction is mildly exothermic, and this last reaction, that is the dry reforming reaction, is also highly endothermic. So the temperature inside the reactor is very high. So due to that higher temperature, decomposition of methane happens. So when methane decomposes, it produces carbon plus hydrogen. And in this, and at side by side also, carbon is oxidized to produce to produce carbon dioxide. Another reaction happens, that is the Boudward reaction, which is 2 moles of carbon monoxide produces carbon and carbon dioxide. So these 5 equations or these 6 equations you need to remember for the syngas production with the steam reforming method, that is from the natural gas method. Next is the, what is the allothermal reaction? What is the allothermal reaction? So, answering your question, what is the water gas shift reaction? What is called water gas shift reaction? So, when we are producing this CH4 plus H2CO plus hydrogen, that is syngas. So, if we want to produce more amount of hydrogen, so suppose we want to produce more amount of hydrogen and we do not want carbon monoxide here. So, then we want to we want to do reaction between the carbon monoxide and the water, that is why which produces CO2 and that produces much more amount of hydrogen. So it is called, that is why it is called the water gas shift reactions. So it is not it is dependent on your requirement. If you require in industry, you may require more production of hydrogen, then you can do this reaction. Is it clear? So CO2 is not part of the syngas obviously, but syngas is called the mixture of CO and H2. So that is a different thing. So maybe in the consequent step we want to produce more number of hydrogen molecules for our purpose, that to react with nitrogen to produce ammonia. So that then we can do that reaction. So CO, and after producing syngas also, CO and H2 can be differentiated and they can be used for individual purposes. Yes, only 1 mole of H2, this is a reaction. So if you produce in a reactor, it will be much more than that. Okay, so allothermal reaction is the reaction where it requires steam with no or little oxygen and heat created from outside of the reactor. So in the autothermal reaction, what we have seen that we don't give external heat to the reaction, but in case of allothermal reaction, we have to give heat from the outside, because there doesn't in allothermal reaction there is no requirement of oxygen in the no presence of oxygen in the reaction. That is why we need to give heat from outside. Next question is the what is the composition of oxygen and methane in partial oxidation of methane? What is the ratio or composition of oxygen to methane in partial oxidation of methane? So here the ratio of oxygen to methane is 0.5. If we keep this ratio, then the efficiency of syngas production will be higher in case of partial oxidation of methane. Next is the hydrogen to carbon monoxide ratio is higher in case of steam reforming compared to partial oxidation. Hydrogen to carbon monoxide ratio is higher in case of steam reforming compared to partial oxidation. It is true because when we steam reformed, then we mix CH4 plus H2O to produce H2 and carbon monoxide. So here H2 is more than the carbon monoxide, but when we do partial oxidation, then we produce more amount of carbon monoxide and lesser amount of hydrogen. Then the ratio will be low. Next is the what is the temperature of the reactor in steam reforming process? What is the temperature of the reactor maintained in steam reforming process? So here the temperature is maintained at 780 Kelvin. So sir has taught the flow diagram here. Yes. In this case, you can see that air and fuel are coming from this side, and here in the reactor, this is a reactor. Here that steam reforming reaction happens, and here the temperature is maintained around 780 Kelvin. So here the answer will be 780 Kelvin. Next is the steam reforming process. In steam reforming process, carbon dioxide is used to control the temperature of the reaction. In steam reforming process, carbon dioxide used to control the temperature of the reaction. True or false? Hmm. It is true. In steam reforming process, carbon dioxide is used to control the temperature of the reaction. Here you can see that from reactor the product is the syngas, and in this case the natural gas is coming in this reactor where process stream and CO2 is mixed. So CO2 and process stream are used to control the temperature of the whole exo and endothermic processes. Next question is the reforming processes occur in the convection section. Reforming processes occur in the convection section. Right. It is the false reaction because in the this is the convection zone and this is the radiation zone. In the convection zone, there's heat is supplied from the exothermic reactions to create that the superheated steam or the flue gas. So in the convection section, heat is delivered from one place to other place, but in the radiation section, reformer reactor is there and the reforming process takes place. So here the answer will be false. Reforming process does not occur in the convection section. Next is the steam to carbon ratio is maintained at what value in case of syngas production. Steam to carbon ratio is maintained at what value? Hmm. It is 2.5 to 4.5 moles of steam per moles of carbon. Next question is what needs to do to improve the hydrocarbon conversion? What needs to be done to improve the hydrocarbon conversion? So here extra stream is added to the reactor, and so that lower partial pressure is maintained, and that will improve the hydrocarbon conversion. Next is the methanol synthesis takes place at 50 to 100 bar. Methanol synthesis takes place at 50 to 100 bar. Yes, it is true. Next is the in syngas production, temperature is high, pressure is high, as well as the steam to methane ratio should be high. Is it true or false? In syngas production, temperature is high, pressure is high, as well as the steam to methane ratio is high. No, it is also true, because in the when the pressure is high, sir has taught in the class that when this pressure is high, it allows for less expensive syngas compression and more compact reformer. Okay, so even if that is thermodynamically unfavorable, but it produces less expensive syngas. So from the point of view of economical purpose, we'll use high pressure as well as high temperatures, and we'll add more steam or surplus steam for the syngas production. Next is the what is the temperature of the combustion zone in syngas production by autothermal reforming. What is the temperature of the combustion zone in syngas production? So here the temperature is 2200 Kelvin because in the combustion zone carbon is oxidized to form carbon dioxide or so in the combustion zone, this reaction carbon plus oxygen to produce carbon dioxide, this reaction is highly exothermic reaction. So that itself produces much more amount of heat. So due to this autothermal reforming, the temperature of the whole combustion zone increases and it is almost near to 2200 Kelvin. So here you can see that oxygen is coming from here and in this combustion zone, and the temperature is almost 200 Kelvin. Next comes the reforming zone, but here the temperature is little less from the combustion one because in the combustion section highly exothermic reaction happens. Okay, so this call is going to end in 10 minutes. I am creating a new link and sending in the chat. You guys join. So can you join this new meeting link and confirm whether it is running or not? Okay. So you also can join that link. Otherwise, I will end this chat. So I mean, I am ending this call. You want to join this call or you see? Okay. So I'm ending this call because it will end in 10 minutes. So okay. Proceeding to the next question. What is the ratio of oxygen to methane in syngas production by autothermal reforming? What is the ratio of oxygen to methane maintained in syngas production by autothermal reforming? So it is 0.6. It is maintained and 0.6. It is the optimum ratio that in industry oxygen to methane ratio is maintained in industry in general. So 0.6 is the answer. Next is the exothermic oxidation reaction is responsible for the endothermic deforming. The exothermic oxidation reaction is responsible for the endothermic deforming. Right, it is true. Because in this autothermal reactor, first the combustion in the combustion zone, oxidation reaction is happening. So it produces much more heat, and due to that heat, this in the reforming zone, due to that heat and the presence of steam, this in the reforming zone, steam reforming happens. So in the steam reforming reaction is endothermic reaction. So uh, this heat is supplied from the combustion zone to reforming zone. So here the exothermic oxidation reaction is responsible for the endothermic deforming is correct. Next is the 11% of coal is used to generate electricity. 11% of coal is used to generate electricity. Yes, it is true, because there are other percentage also in other applications. So 32% is used in chemical industry, 11% is used in generate electricity, and 8% is used in gaseous fuels. So here the answer will be true. Next is the discuss the coal gasification reactions. So we have discussed the steam reforming reactions. Now discuss the coal gasification reactions. Yes, so there are set of heterogeneous reactions and set of homogeneous reactions. So in case of stream reforming, natural gas was our feed. So that is the methane was our feed. But here, that is coal is our feed. Coal is represented as carbon, that is C. That is C plus steam produces H2 plus CO. So this is the syngas. Next, this carbon next this carbon can react with carbon dioxide to produce 2 moles of carbon monoxide. Also, this coal can be oxidized to produce 2 moles of carbon monoxide. Another reaction happens in the heterogeneous reaction. This is carbon reacts with hydrogen, produces methane. Then the methane can be steam reformed to produce syngas. Okay, so why it is heterogeneous reaction? Because here that is carbon is in solid phase and H2O is in vapor phase, that is steam. So here the both physical state is different, that is why it is called heterogeneous reaction. Next comes the homogeneous reaction. So in the coal gasification reaction, there are some part where homogeneous reactions happens. So under the homogeneous reaction, previously produced carbon monoxide reacts with oxygen to produce carbon dioxide. This is a highly exothermic reactions, and previously produced carbon monoxide reacts with steam produces mixture of carbon dioxide and hydrogen. You can see that here there is no direct production of syngas, that is CO plus H2 mixture, but individually CO and H2 are produced. So these are the reactions happens in the gasification reactions. Next question is what is pyrolysis? What is pyrolysis? So what is the definition of pyrolysis? So pyrolysis is the thermal decomposition of a substance in a non-reactive atmosphere at high temperatures. An external heat source is applied to maintain a temperature which is typically in the range of 300 to 850 degrees centigrade. The output from the pyrolysis process is a solid residue and a synthetic gas or syngas. Okay, so this solid part is the char and and the gaseous part is the syngas. So when we burn something at very higher temperature, it produces some black solid parts and some kind of gas. That black part is called the char and the gas is the syngas, and this whole process is called the pyrolysis. Next is the in pyrolysis network, what comes after thermal decomposition? In pyrolysis network, what comes after thermal decomposition? So here the answer is formation of radicals. If you see the pyrolysis network, if you see this pyrolysis network, first is coal is thermally decomposed, then formation of radicals are happening. So after thermal decomposition, here the answer will be formation of radicals. Next is the what is going to form after stabilization of the radicals. What is going to form after stabilization of the radicals? Yes, here the answer is B. Radicals are condensed to form char. Is it true or false? Radicals are condensed to form char. Is it true or false? Right, it is true. If you remember this pyrolysis network, then we will able to answer all of the questions. So these radicals are polymerized or condensed to form char. So it is the basic question, what are the steps of pyrolysis network? You can tell from that chart only. What are the steps of pyrolysis network? So the steps are cold thermal decomposition, formation of radicals, polymerization, condensation, stabilization, exposed to temperature, secondary gas phase reactions. So here you from here you will understand more clearly that coal is thermally decomposed. That means at higher temperature coal is decomposed to produce radicals. Then it is polymerized or condensed to produce char gas along with H2 or CO. That means a syn gas is also produced. In the other step, the stabilization of these radicals produces syngas, these two aromatic structures or many more other molecules also. Now, if these radicals are exposed to higher temperature for a longer period of time, they will do the secondary gas phase reactions. So after secondary gas phase reactions, acetylene, CH triple bond CH, syngas and other these aromatic phenolic compounds are also produced. So this is the whole process is called the pyrolysis network. Next is the at higher pressure methane conversion is higher compared to low pressure. At higher pressure methane conversion is higher compared to low pressure. So it is true. Why? Because we know that in the gasification reaction, methane formation is the reaction between carbon and hydrogen, right? So it is an exothermic reaction, that means it produces heat. So after some time, the if the reaction temperature is much more high, then according to the La Chatelier principle, it will prioritize the backward reaction rather than the forward reaction. So if we prioritize the backward reaction, then methane methane will produce less with time. Methane will produce with less with time because it crosses its optimum temperature. So here you can see that in this diagram, composition versus temperature diagram, initially methane composition was 20%, then methane composition 20%, then at the temperature increases, the methane formation is decreasing because at after a point it will not produce methane anymore. So this happens in the 1 bar pressure. So in the 30 bar pressure, this curve will this maxima will shift a little bit. Okay, so the conversion is little bit higher than in case of 1 bar pressure. So due to this, we have said that at higher pressure methane conversion is higher compared to lower pressure. Next is the as pressure increases, both carbon dioxide and methane maxima migrate to higher temperature. As pressure increases, both carbon dioxide and methane maxima migrate to higher temperatures. So as pressure increases, both carbon dioxide and methane maxima migrate to higher temperatures. It is also true. It is the same reason like the previous one. Here you can see initially CH4 formation is an exothermic process. So after a certain temperature, the backward reaction will be preferred. The backward reaction will be preferred, and that is why the composition of CH4 decreases with temperature, and in the higher pressure this maxima will shift a little bit. In case of CO2 also, carbon dioxide also, the same thing happens because carbon dioxide production is also an exothermic one, and after higher temperature is reached, the backward reaction will be preferred, and at the higher pressure also this maxima will be there, but it will shift little bit. So as pressure increases, both carbon dioxide and methane maxima migrate to higher temperature. It is true. Next is the in autothermal process, carbon monoxide produces less compared to hydrogen. In autothermal process, carbon monoxide produces less compared to hydrogen. Correct. In autothermal process, hydrogen hydrogen is produced in less amount rather than the carbon monoxide. So the next question is, at higher pressure, oxygen to steam ratio reduces. At higher pressure, oxygen to steam ratio reduces. Is it true or false? The answer will be true. At higher pressure, oxygen to steam ratio reduces. Then, at 1600 Kelvin, how much enthalpy is required per mole of steam? At 1600 Kelvin, how much enthalpy is required per mole of steam? Yes, it is 135 kilojoule. Then the question is, at low temperatures exothermic processes play a role, but as the temperature rises, endothermic reactions play a larger part, resulting in the greater enthalpy change. At low temperatures, exothermic reactions play a role, but as the temperature rises, endothermic reactions play a larger part, resulting in greater enthalpy change.
False, ma'am. False.
No, it is true because at low temperatures, exothermic reactions happen in the forward direction. Okay, but after the temperature rises, it does not it does not prefer to happen the forward reaction. It then if the temperature is removed from the exothermic reactor to the endothermic reactor, then it helps in the greater enthalpy, maintaining the greater enthalpy change and completing the next reaction. So it is true here. Now, this moving bed gasifier runs counter currently. Is it true or false? This moving bed gasifier runs counter currently.
True, ma'am. It's true.
No, it is true. Because in the reactor here, coal is coming from one side and steam is coming from another side. So it is the counter current. Next question is why is jacket steam is used in moving bed gasifier? Why is jacket is used in moving bed gasifier? So here the answer is to control the reaction temperature inside the reactor. You can see that this is the moving bed gasifier, right? So coal is coming from the top and steam is coming from the bottom, and in this reactor combustion reaction happens where C plus O2 produces carbon dioxide and then the gasification reactions happen. So combustion reaction is highly exothermic. So to control the temperature, cooling jacket is used in the moving bed gasifier. Next, the higher temperatures are obtained at which zone in the moving bed gasifier? Higher temperatures are obtained at which zone of the moving bed gasifier? Hmm. Combustion zone, it is obvious because in the combustion zone exothermic reactions happen. So here temperature is higher. What is the slagging temperature? What is the definition of slagging temperature? Yes, at this because in the high temperatures minerals also can get sticky or it can melt. So that is the slagging temperature. Now energy efficiency of the process is enhanced because of the counter current operation. Energy efficiency of the process is enhanced because of the counter current operation. Hmm. It is true because in the moving bed, this is one of the advantages of the moving bed gasifier. In the moving bed gasifier, temperature is maintained at 2000 Kelvin, whereas the temperature is maintained in 1300 Kelvin in case of slagging gasifier. Is it true or false? In moving bed gasifier, temperature is maintained at 2000 Kelvin, whereas in slagging gasifier, temperature is maintained at 1300 Kelvin. Is it true or false? Right. It is false. It is the opposite. In slagging gasifier temperature is 2000 and normal moving bed gasifier temperature is 1300. Next is the slagging gasifier does not have spinning rate in combustion zone. Slagging gasifier doesn't have spinning rate in the combustion zone. It is also false. No, it is true. Because it is written here that in the standard reactor has a grate, but the slagging reactor has a combustion zone without the internals. That means without the grate. So here I have asked that it does not have a spinning grate in combustion zone, so it will be true. Okay, it will be true. Next is the fluidized bed gasifier is a back mixed reactor. Fluidized bed gasifier is a back mixed reactor. True or false? Right, it is true. Next is the what is the advantage of fluidized bed gasifier? What are the advantages of fluidized bed gasifier? The answer is excellent mass and heat transfer arises from the intense mixing. As we have just saw that fluidized bed gasifier is a back mix reactor. So all the so what is inside the reactor? What are the chemicals inside the reactor mixes very well with one another, and that leads to the excellent mass and heat transfer. That inside the fluidized bed gasifier, the reactant molecules uh, produces a homogeneous mixture, so it gives excellent mass and heat transfer, and that is the advantage of fluidized bed gasifier. Next is the char particles are recovered in cyclones in moving bed gasifier. Char particles are recovered in cyclones in moving bed gasifier. So here the answer will be false because it happens char particles are recovered in case of fluidized bed gasifier, not in case of moving bed gasifier. It will be clear from the diagram only that here the reactions happens inside the reactor and this char particle along with the syngas went to this portion and raw syngas is collected from the top and the cyclone and through this cyclone that char particles are collected and they are again mixed to the reactor. So here it will be false. Next is the why crushed coal is used in fluidized bed gasifier. Why crushed coal is used in fluidized bed gasifier? Here the answer will be in fluidized bed the coal particle sizes are very small because we know that small particles provide higher surface to volume ratio which leads to good mixing or complete mixing between the reactant molecules and thus the production will be much more efficient compared to the moving bed gasifier. So that is why coal are crushed in the feed and that is used in the fluidized bed gasifier. Next is the at what percentage fluidized bed gasifier can convert carbon? At what percentage fluidized bed gasifier can convert carbon?
95, ma'am, 95%.
Yes, it is actually in the range of 95 to 97. So 95 will also be the correct answer. 97 also will be the correct answer. Next is the highly reactive coal is the feed for fluidized bed gasifier. Highly reactive coal is the feed for fluidized bed gasifier.
True, ma'am. Ma'am, it is true.
It is true. Highly reactive small crushed coal is the feed for fluidized bed gasifier. Entrained flow gasifier can process all forms of coal. Entrained flow gasifier can process all form of coals. True or false?
True, ma'am.
Yes. So is true. Entrant flow gasifier can process all form of coals, and this fluidized bed gasifier process only the reactive coals, and the previously moving bed gasifier process only the non-caking coals. So here it can process any kind of coal. So it is true. Next is the which gasifier has a residence time of few seconds. Which gasifier has a residence time of few seconds?
Entrained bed, ma'am. Entrained bed gasifier.
Yes, the answer is entrant bed gasifier. Next is the in entrant flow gasifier, coals are heated at a certain at 1000 Kelvin per second rate. Is it true or false? In entrant flow gasifier, coals are heated. Any kind of coals are heated at 1000 Kelvin per second.
It is true, ma'am.
Right. It is true. Next comes the what is the coal gas efficiency? What is the definition of coal gas efficiency? So the answer is the ratio of chemical energy in the syngas production to the chemical energy of the given coal. Okay, so this is the general efficiency definition. The chemical energy required to produce the syngas and the chemical energy required chemical energy given through the entering coal. Next is the which gasifier has a low coal gas efficiency? Which gasifier has a low coal gas efficiency? No coal efficiency. Which bed has a low coal gas efficiency? Yes, the answer is entrant bed because in the moving bed moving bed gasifier, there in the product not only syngas is produced, along with syngas some other kind of phenolic compounds are also produced. So their the product energy is much more higher than in case of the uh, entering coal energy. But in case of entrant bed, what happens? Only the syngas produces, so the product chemical energy is lesser than the entering coal energy. So that is why entrant bed coal efficiency is low. Next is the what type of coal is used in fluidized bed gasifier? What type of coal is used in fluidized bed gasifier? I think it is already told. It is reactive. It is the reactive one. Next is the what is the coal size in entrant flow gasifier? What is the coal size in entrant flow gasifier?
Option D, ma'am.
Yes, option D. Next is the what is the inlet and outlet temperature maintained in the entrant flow gasifier? What is the inlet and outlet temperature of coal in gasification reaction maintained in entrant flow gasifier? Here the answer is in the reactor the initial temperature is inlet temperature is 1600 to 22 in the entrant flow gasifier, and when the product is formed the temperature range is 1200 to 1850. Next is the entrant flow gasifier and moving bed gasifier have highest carbon conversion. Entrant flow gasifier and the moving bed gasifier have highest carbon conversion compared to the fluidized bed gasifier.
True, ma'am.
Yes, it is true. Next is the what is the oxygen consumption in case of moving bed? What is the oxygen consumption per kg of coal in case of moving bed? Here the answer is 0.43. So in the
Right.
chart itself, sir has taught in the comparison chart. It is oxygen consumed is 0.43 in case of moving bed, 0.71 in case of fluidized bed, and in case 0.8 to 9% in case of entrant bed. Next is the fluidized bed gasifier has highest cold gas efficiency. Fluidized bed gasifier has highest cold gas efficiency.
False, ma'am.
Uh, it can be true also because like it is higher than the entrant one. So here also you can say true. Though there is moving bed also. Moving bed efficiency is 84% and fluidized bed is 81 to 85. So the range is similar. So here you can say the true also.
Okay, ma'am.
Next is the what is the throughput in entrant flow gasifier? What is the throughput in entrant flow gasifier? That means what is the product? What amount production happens in case of entrant gasiflow in entrant flow gasifier? So it is 5000 tons per day. In case of fluidized flow gasifier, that is 3000, and in case of moving bed, it is around 1500. So entrant flow gasifier produces much more amount of syngas than those two. Moving bed gasifier has the most complicated gas composition. Moving bed gasifier has the most complicated gas composition. It is true because In moving bed gasifier, it operates in lower temperature range. So in lower temperature range, you can see from this chart. So this region is for moving bed. It works around the 600 to 1000 Kelvin temperature region. So here not all the carbon or carbon dioxide forms converts to carbon monoxide or hydrogen. So there are still there are other compounds along with the syngas also. Maybe some kind of phenolic compounds or some kind of hydrocarbon also are there. So moving bed product has complex composition. But if we see the entrant gasifier, you can see the in this region 1400 to 1800 region, only the syngas produces. No other components are available here. So only the carbon monoxide and H2, that is the syngas is there. That is why this answer is true. Next is the incandescent gasifier produces higher hydrogen to oxygen ratio.
True, ma'am.
Yes. One minute. No. Here it is written that entrant flow reactor is run with a higher oxygen to coal ratio and less steam, results in a lower hydrogen to oxygen ratio. That means in entrant flow, lower hydrogen produces than the carbon monoxide. More carbon monoxide produces than hydrogen. That is why this ratio will be less. Next is the what are the composition gases available in the syngas. What are the composition of syngas in the when it is out from the gasifier? So only syngas is not produced, right? Along with syngas, other compounds are also produced in certain amounts in each of the gasifiers. So what are the compounds? So mainly syngas is produced, that is CO, then hydrogen, then water is produced, then carbon dioxide is also produced, then methane is produced, then in some amount COS is produced, hydrogen sulfide is produced, then ammonia and mixture of ammonia and hydrogen cyanide is can be also can be there, and as and some nitrogen and argon are also can be there in the product. So not only syngas is produced, along with syngas these are also produced. But in case of moving bed, these components percentage are much more. But in case of entrant gasifier, these other components have less are in less amount rather than in syngas. So in the entrant gas, only the syngas is there. Syngas percentage is much more higher. Next is the which type of entrant gasifier has highest coal gas efficiency. These are all some kind of entrant gasifier. So which one has the highest coal gas efficiency? Question 61. Yes, sir. Yes. Say. So in the entrant gasifier, highest cold gas efficiency happens in case of shell entrant gasifier. Shell entrant gasifier has the highest cold gas efficiency. The last question is the in traditional pulverized coal power plant, how steam is produced? In traditional pulverized coal power plant, how steam is produced? So the answer is already there in the lecture. Steam is produced by exchanging heat between the boiler feed water and the flue gas from a pulverized coal combustor. So in the pulverized coal combustor, flue gas is present and water is boiled more than 100 degrees Celsius. So by mixing these two, steam is produced. By not mixing, by exchanging heat, this steam is produced, which are used in the coal power plant. Okay, so this is from my side. You have a doubt in question 61? Yes. Oxygen to coal ratio in less steam results in oxygen to coal ratio in less steam. So here you can see that in the entrant flow gasifier, CO composition of CO is around 0.7%, whereas hydrogen is produced in around 0.4%. So carbon monoxide presents in higher amount than the hydrogen. That is why if we compare it with the ratio of oxygen, hydrogen to oxygen ratio, so here if we compare the hydrogen to oxygen ratio, it will be less in case of entrant gasifier because the production of hydrogen is less in the entrant gasifier rather than the production of carbon monoxide. Okay, so this is the answer to your question. Any other?
No, ma'am.
Okay, so where are you from?
Hello, ma'am. I'm from Haryana.
Okay, okay. So you are the BTech student?
No, ma'am. I have completed MSc in chemistry, ma'am.
Okay, okay, okay.
Yes, ma'am.
Thank you for joining in. I am ending this call.
Thank you, ma'am. Ma'am, I have one query also.
Yes, yes.
Ma'am, can you please upload a PDF or PowerPoint of these lectures?
Actually, I am not authorized to do that. The NPTEL team does this, the upload of lecture and PowerPoint. Maybe they will upload it after the completion of the course, but not before that. So what you can do, you can just take screenshot of the lectures what sir has taught. So
Oh,
yes, that is what you can do. Yeah.
okay, ma'am.
Okay. Thank
Thank
you.
you, ma'am.
Thank you so
Thank
much.
you.